Okay, thank you. My name is Henrik Finsberg. I'm also at Simla, sharing office with Jørgen. I work as a research engineer in the computational physiology department, and I maintain a large number of packages related to cardiac modeling and brain modeling. So I'm here to basically showcase some of these packages today and talk a little bit about the infrastructure around software development. Okay, so at Simla we do a lot of cardiac and brain modeling. So typically for brain modeling we take clinical data such as MRI images, generating meshes and simulate the fluid flow in the brain. And then we can create this nice visualization here, which is by Marius Kausmann, which we'll present later this week. For cardiac simulations, we typically do more multi-scale modeling, where we simulate both the heart at the single cell and tissue level, and combining these multi-physics models together, as well as creating digital twins. And for the brain meshing pipeline, we have a working pipeline where we typically start with the segmentation of the brain, where you have the different regions of the brain labeled. We do some image processing, extracting the regions of interest using scikit image, and then we use pyvista for extracting the surfaces. And once we have these different surfaces, we can mesh them together using wildmeshing or the wrapper pytet wild to create the tetrahedral mesh. And this pipeline also goes internally under the name the Marius pipeline, so after the creator. Here are some of the repositories we have where we use this pipeline. So if you are interested in creating kind of complicated meshes, I would recommend to check out some of them. When working with brain data, we typically use a lot of MRI images, and we need to do some sort of processing of these. And for this, we created this MRI-toolkit, which is primarily based on a work of a former PhD student called Jørgen Riseth, where we basically can extract and manipulate these and extract different type of data from these images. And if you're also working with brain segmentation, I would also recommend to check out this BrainSeg. The MRI-toolkit is also maintained by Cecile, and Andreas has also been contributing to that, which they both will present also later this week. We also have a large number of packages for the simulating the heart. Some of them are listed here. For creating geometries, we have the cardiac geometries package, or cardiac geometries X. That's what we do now, to add an X to the end of the package when we have a new version. And then we have FEniCSx LDRB for creating these cardiac muscle fiber orientations, which is used for characterizing the material properties in the heart. For doing tissue level electrophysiology simulations, we have something called FEniCSx-based, and for co-generation of single cell models in the heart, we have something called GoTranX. For cardiac mechanics, we have something called FEniCSx-pulse for simulating the tissue level continuum mechanics, which can also be coupled to a package for simulating the cardiac circulation system called Circulation. And all of these libraries are, of course, backed by SciFem and IO for DOLFINx, which you saw Jørgen just presenting. So I will not talk about them anymore, and also DOLFINx adjoint, which is also quite experimental at the time, but those are work in progress. So over to kind of the user. So once we have all these packages, it's of course important for us to be able to distribute them to users. So we typically push our code to GitHub, and then we want to distribute them to users using kind of the four main channels that we have already seen earlier today: Spac, Conda, PyPI, and Docker. And for those of you who haven't used that, I think most of you have. These are kind of the four ways of installing this package. For example, this FEniCSx-pulse package, if you want to do that. And for PyPI, in order to distribute your package with PyPI, we typically add a GitHub action, in a .github folder, which is run on every push and pull request to the repository. And then we have set up so that whenever there is a new tag or release push to the repository, it will upload the wheels to PyPI automatically, which can be set up with something called Trusted Publisher. And a note here is that DOLFINx is not yet on PyPI. I know Jack is kind of working hard on this, and maybe in the future we will have this. But for now, if you want to install a package, one of the packages with pip, then you need to install DOLFINx in a different way. For example, if you're in a Docker container, for example. And also note, if you are building packages with extension modules, I would recommend checking out the CI build wheel, which can build wheels for different architectures. Conda, we also try to ship Conda packages on Conda Forge. Here is kind of a Gemini version of how to add a package to Conda. You basically start with building what's called a recipe, and then you basically fork the Conda stages recipe repository and make a pull request. That's basically the pipeline, and then you will need to make sure your package builds, and then it can be merged into the Conda Forge repository. There is also a tool called Grayskull. So if you have your package already on PyPI, for example, you can generate a recipe automatically with this tool, which is quite nice. If you want more elaborate example, you should check out the SciFem recipe, which also contains kind of instructions on how to build a recipe for if you have an extension module, for example. SPAC, we also build or create SPAC packages for all our, or most of our packages. We also, similar to FEniCS, we have our own SPAC repos where we basically upload all our packages with the new versions, because we got a bit tired of waiting for SPAC to merge our pull requests. So you should just make sure when you create a new environment to add the FEniCS repo and our repo if you want to use our packages. Then SPAC will pull those packages from those first. And when working with multiple developers, it's often a good idea to agree on some coding styles, because this is the root of many disagreements. So what I prefer is to use pre-commit. This is basically, you specify a file, a pre-commit.config file, where you specify all the kind of checks you want to be run. And this will then be run whenever you type git commit. So that whenever you commit, you cannot commit any bad code. So here you can specify, for example, that ref should be run, or mypy, or any other hooks that you can also write your own hooks, of course. And once you have all these hooks in place, it's also good to keep them up to date. For example, if there is a new version of rough, you can use something called pre-commit CI, which is basically a bot that you can add to your GitHub repository, which will then create pull requests every now and then when there is a new version. Similarly, it's also a good idea to keep your GitHub actions up to date. And then this you can do with adding what's called a dependabot. And the nice thing about this is also that it makes sure that your tests are regularly run, even though you are not maybe pushing to the repository that often. It makes sure that your code is kind of continue to work if you have tests, of course. Finally, software documentation is also very important for reaching out to the users. There are a bunch of different tools for creating documentations. I tend to prefer using Sphinx for now, which is a very mature tool for creating documentation. It's also very good for API documentation. We used JupyterBook a lot in the past. This has kind of migrated now in the new version to something called MistMD, which doesn't have all that good Sphinx support, although I think that's something they are working on. MKDocs is also another popular documentation library, which seems to be discontinued in favor of something called Sensical, but this seems to be quite experimental. Current version is 0.043, so yeah. And then there are other players such as GreatDocs, which I think is promising, and that's built on something called Quartal. So that's something to maybe check out in the future. And then we try to host all our documentation on GitHub pages and set up some sort of GitHub action that makes sure that you build documentation whenever there is a push to the repository. So here's just one example for the FEniCSx Pulse documentation. I guess many of you already kind of know how to build this documentation. This one is built with Sphinx, previously JupyterBook. There's also like a conversion script for just converting your config file from JupyterBook to Sphinx if you are interested in doing that. This also contains a lot of examples. And the nice thing about building a documentation in the GitHub action is that you will also make sure that your examples continue to run when you push to GitHub. This one also has some interactive visualization, so there are some environment variables you need to specify here to make that work. Okay, that was all. I think I'm already past my time. So just here are some more links. I also leave a link to the actual presentation if you're interested. And thanks to the KG Epson Center for Brain Fluid Research for sponsoring me. Thank you.
Okay, thank you, Henrik. Any questions for Henrik? Yeah, Remy.
Thank you very much. I'm curious about your reason for moving away from JupyterBook. We use JupyterBook quite a lot, the version 1.
Yep.
We haven't migrated to version 2, I think, for the same reasons.
No, yeah.
Why have you switched to Sphinx?
I think, so the main reason is that this API documentation was not really working that well. So when you have your doc strings in your Python code, you can automatically generate the API documentation from that, and I think that was not really working. It might be working now, I haven't checked recently, but that was the main reason. And yeah, there are also some other small things I don't remember exactly, but yeah. But I think the new JupyterBook looks very nice. So I think that's, yeah.
Okay, thank you, Henrik.
Thank you.
Now, let's just give Henrik a round of applause. And Dan.